and increase that value by 5, I am 20. Okay, I want you not just give me the answer, but also explain like what happened and how did you find out? Explain that. Okay, we are starting in 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, let's take a look. 5 is the answer because 5 times 3 is 15 and 15 plus 5 is 20. Okay, 5, if you multiply by 3 and add 5, you get 20. 20 subtract 5 is 15, and 15 divided by 3 is 5. Okay, so here we see different approach. We see different approach. Some are saying, okay, if you it is 5, you multiply by 3 is 15, add 5, you get 20. So you are you're testing. Maybe you tested 5, you tested 3 or 4. You say, okay, 5, because I verify it will make 20. But I also see a different approach here. And this one says 20 subtract 5 is 15. So it's a different approach. And 15 divided by 3 is 5. And why did you do that? Why did you do 20 subtract 5? And then why did you do 15 divided by 3? Number is 5, because you do 20 subtract 5 is 15 divided by 3, which give you 5. Okay. You solve the problem backwards. Okay, I like that. Backward, that's a key word here. Multiply 5 by 3, you get 15. If you add that by 5, you get 20. Okay. All right. Okay. So here's class. I want to bring your attention to this. We are basically having two approaches to this question. Let me bring out our sketchbook. So let me paste it here. And today is August 26th. August 26th. And today our topic is algebraic thinking. Algebraic thinking. Okay, so let's start from this question. So basically, we have two approaches. I'm going to write both of them down. So first, approach A is someone says 5. They say the number is 5. So they say, okay, this is a number. You multiply by 3, it's a 15. And increase that value. So 15 plus 5 is a 20. So this is one approach. And the second approach is they do it backwards. So they do it backwards. They do it backwards. And what they do is 20 subtract 5 is 15. And 15 divided by 3 is 5. And then say, okay, this is the answer, this is the answer. Right, let's compare these two approaches. Yes, I believe that both of you, you gave me the correct answer. But let's consider the first approach. You begin with 5, right? You begin with, okay, the answer is 5. And then you do it, you do all the steps, you say, okay, now I get 20. But the question is, how did you get to that 5 in the very beginning? And also, like if I change this, like if I change this to if you multiply me by 4.03443 and increase that value by 1.57, then I get 291. Okay, if I change the question a little bit, can you still get the answer? Like, can you like actually see the answer like immediately? Can you actually see the answer? Well, you will find out like if I change the question a little bit, then it's impossible for us to see the answer right away. We can see the answer because it's so easy, it's so simple. But if I change the question a little bit, then that's impossible for us to see this 5 or whatever number it is. Today, we are going to learn this second approach. And that second approach, you can think of it as backwards, or I prefer to call it algebraic thinking. So let me explain to you. So let's consider this question from a different approach. If you multiply me by 3 and increase that value by 5, I am 20. And some people say, okay, let's do 20 subtract 5. And then let's do 15 divided by 3. Then we find out 5 is the number. Well, you are actually using the algebraic thinking before you even know it. So yesterday we said with algebra, the meaning of algebra is to use symbol to represent actual numbers. So we don't, like if there's a number we don't know, we use a symbol to represent that unknown number. So that's a core, that's a key to algebra. So with this question, if you multiply me, okay, we don't know what is me. We don't know what is me. So here we are using a symbol, let's say X, or if you prefer, you can use a different letter, maybe A or B or C or X, Y, Z or M, N, O, P, any symbol. We are just using a symbol. So this X stand for me, okay? So this is a huge change. So the first thing, if you want to master algebra, is you gotta be comfortable with using symbols, right? So this is the key. This is a great leap. So we are using a symbol, a letter, to represent for me or that number. Okay. Once we get this, and things can be, you're seeing a whole different new world. So you multiply me, so we are multiplying that letter. So the X will multiply by 3, so X times 3, and increase that value. So that value is the result of X times 3. So we will, after we get X times 3, we will increase that value by 5. We'll add 5. And I am 20. That means I am equal to 20. So this is how algebraic thinking, the way how it works. We use a letter to represent an actual number or unknown number. Okay, we don't know what is me, but we just use a symbol. And from there on, here are the steps. Since this value, X times 3 plus 5 is 20. And then if I, without adding that 5, this X times 3 should be 20 subtract 5. So this X times 3 is 15. We do some operations with this equation, and then we find out, okay, X times 3 is 15. Okay, if X times 3 is 15, then X itself is 15 divided by 3. So we do another operation with that equation. Then we find out X is 5. And why do we need this algebraic thinking? So let's go back to our sketchbook. So like I said, without algebraic thinking, if I change the question a little bit, let's say we are not like multiply me by 13 and increase that value by 15, and I am 2020. Okay, I change this question a little bit, then our original approach, it won't work. We cannot see what is me, but we can still work with algebraic thinking. So we can say, after you change this question, we still use a letter X to represent me. Okay, this is the number we are looking for. This is me. Multiply by 13, so X times 13. X times 13, and increase that value by 15. So after I have X times 13, I increase that value by 15, and that equals to 2020. And from there, I can see, okay, this part plus 15 is 2020. So that means this part alone is equals to 2020 subtract 15. And that will be 2005. Therefore, I can say X times 13 is 2005. And I can do, okay, so 13 times X is 2005. So X is 2005 divided by 13. And here on, you can use a calculator. So if we use calculator, probably we'll find out that to be, let me quickly use my calculator. 2005 divided by 13 is, okay, 154.23. 154.23. Okay. So we have the answer. As you can see here, it's impossible to just get this 154.23 using this method. You can never just immediately read it's 154. But with this algebraic thinking, we solved it. We find out. So that's the power of algebraic thinking. And the secret is use a letter, use a symbol to represent some unknown value, some unknown number. Okay, so this is the most important message I want to deliver to you. This is the most important message I want to deliver to you. And this is probably the most important message you need for algebra. So here, let's pause, and I want to see how do you feel right now. How do you feel right now? Okay, tell me. How do you feel right now? Totally lost, a little confused, or you are getting this? Let me know how do you feel. Okay, so I think I'm seeing probably 70%, 75%. You're getting this, maybe 25% like you're a little confused or you feel you're lost. Okay, I see. Thank you. I think maybe 30% a little confused. Okay, and 70% are getting this. Cool. Okay, let me give you another example. So remember the trick we did yesterday, right? Yesterday we did this trick. We say think of a number and double that and add 10 and then halve it and then take away your original number. And we say, okay, that result will always be equal to 5. We are using algebra, and the key to algebra is using a letter to represent unknown value. So there's a number we don't know, so we are using x. We say, okay, that number is x. We use this letter for that. So think of a number, okay? First step, okay? I think of a number x. Double that. So double means x times 2. Third, add 10. So based on what we have, x times 2, and then I add 10. Fourth, halve it. So this thing, let me use a different color. This thing, I will halve it plus 10 and then halve it. So this is our fourth step. So this is step 1, step 2, step 3, step 4. And lastly, we take away from step 4. So step 4, I just copy step 4. Then I take away original number. That original number is x. Okay, so this is how this trick it has been constructed. It has been constructed. As I said yesterday, if you simplify this final expression, you will see it will always be equals to 10. It always equals 5. It always equals to 5, right? So I'm not going to actually do this again. So we'll learn how to deal with an algebraic expression in the future. But I just want you to see that what's behind that trick is algebra. This is algebra. Okay. I hope this might help you give you a better idea. And but question is is algebra only works with numbers like it's just like a trick or game something? No, actually algebra is everywhere. It's everywhere in our daily life, in everything. Okay, let me give you another example. So here, consider this. If we have a rectangle, the length of a rectangle is 6 inches more than its width. The length is 6 inches more than its width. If the perimeter of the rectangle is 24 inches, find its dimensions. Okay, I believe maybe without algebra you are still able to find the answer. Like you can try. If the width is 1 inch and then the rectangle is how long and then what is the perimeter, you might still be able to answer this question. But as I always say, if this question gets more difficult, let's see, if the perimeter of the rectangle is not 24, it's 99 or 268. When the problem gets more complex, it's not impossible and it's not possible anymore for you just to see the answer. And there's when we need algebra. So we say with, we give it a letter. We say this is our width, and therefore length is 6 inches more. 6 inches more. So this is going to be our length. Therefore, width plus width plus length plus length. This is also our length. This is our width. It's our perimeter. And that is a 24. That is a 24. And from here, we can do, that's 1, 2, 3, 4. That's going to be 4W plus 6 plus 6. That's plus 6 plus 6 is 24. 6 plus 6 is 12, and that's 24. So 4W, this part, plus 12 is 24. So 8 is equals to 24 subtract 12. Therefore, 4 times the width is 12. And width is 12 divided by 3. And by 4. By 4. And the width is 3. The width is 3. Once we have the width, we can easily find out the length. The length is 6 more. So the length is 6 more than width, which is 3 plus 6, and that is a 9. So we solved it. We solved it. For this rectangle, the width is 3, and the length is 9. The length is 9. Okay? And the most important thing with this one is, even if this gets really hard, like this is not 24 inches, if they are not equals to 24, let's say, if they are equals to 999, we can still solve it because we only change this part. We only change this part, but we can still solve it with the same method. So this is how we can use algebra to help us with the questions, the problems. Okay, sorry class, I'm back. So this is a very important about algebra. So let's go to another question. So the question is, if there are total of 35, so chicken and rabbit, the total is 35 on the farm, and the 94 total legs. So we are counting legs. So the chicken and rabbits, the total is 35, but their legs, the total is 94. Now, how many chickens and how many rabbits are there on the farm? So I want you to consider this question, and probably you can share with me. So share with us. How would you approach? How many legs each animal has, and you will divide what divided by what? How many legs a chicken has, and how many legs a rabbit has? Okay, that's a very good starting point. So apparently a chicken has 2 legs and a rabbit has 4 legs. Yeah, and what's next? Thinking about how a rabbit has 4 legs and a chicken has 2 legs, and then what? You divide what? The amount of legs subtract the total amount of animals. So you're saying we use 94 legs subtract the total 35 animals, and what would that give you? Remember, I want you to practice using a symbol to represent. So we are looking for the number of chicken and the number of rabbits. So think, how can you use a letter or symbol to represent the thing you are looking for? Divide by half, give 1/2 to the ducks. I think you mean chicken, and 1/2 to the rabbits, and then what? 59. What is that number? We are asking you for a number of chicken and number of rabbits. What is that number for? I would multiply, then add both of the legs. How many legs they all have, then divide. Total there are 35, and then a bunny has 4 legs and the chicken has 2. Okay, yes, you're right. But what's next? I would figure out how many legs a chicken has and how many legs a rabbit has, and then what do you do? Okay, so let's give it 30 seconds, and after that, I will share my ideas, my algebraic thinking. 3, 2, 1, 0. Okay. So class, I really would love to give you more time to think about that, because this will really help you. Like, just think about how I approach a question. This will really, really help you. But we are running out of time, so I will go ahead and share with you my thoughts. Okay, see here. Here's my thoughts. I am using letters. As you can see, I am using C for the chicken and R for the rabbits. So I'm using two letters. And I say, okay, what I read here is the total of chicken and rabbits are 35. So that means C plus R is 35. And another information I know is that total legs. So we know chicken has 2 legs. So for each chicken, it has 2 legs. So the legs for our chicken is 2 times the number of chicken, 2 times C. And each rabbit has 4 legs. So the total legs for rabbits is 4 times the number of rabbits. So that's the total for the number of rabbit legs. And they add up chicken legs plus rabbit legs. The total is 94. The total is 94. So now I have 2 information here. First, chicken plus rabbit, the total is 35. I think you can see that. And second is the total legs for chicken, that's 2 times C. And the total legs of rabbits, that's 4 times R. And they add up to be a total of 94. A total of 94. And then we only need to solve for C and R, Okay. So I think I will probably stop here. I will leave the rest to you. I will leave the rest of the question to you. So tomorrow, when you come to class, I will ask you, okay, tell me, how did you approach this? How did you go on from here? And how did you solve this problem? Okay, so think about this one today, and tomorrow, I want you to tell me, how did you solve the rest of the question? Okay, so this is what we talk about today. It's about algebraic thinking. Remember, we need to use symbol or letter instead of actual number when we don't know that number. When something is unknown, we use letter and symbol to help us. Okay, so that's all for today. And before we go, I want you to take 1 minute and probably give us some idea about, pause and write what you've just learned. Okay, write down what you learned today, and meanwhile I will do attendance. To solve and find x value for x and other exponents, thinking can help you rethink. Learn the proper way to approach a question like this, different ways to be a good algebraic thinker. Great. I learned how to do algebraic problem. More about math. Okay, I can use equations. Yes, that's a great one. How to set up. Yes, that's important. How to set up. That's very, very important. Learn the backward way. Okay, cool. Gets bigger, somewhat harder, so you have to use algebraic formulas. Yes, great. Cool. Learned about algebraic thinking. Cool. Using multiplication should divide, be more efficient. Okay. Algebraic equations can be used from any type of situation. Cool. Yes. I learned different algebraic equation. We learned about algebraic thinking. Cool. Great. Class, I think you did great job. I hope like today, if you have some time, you can maybe discuss what you learned, maybe with your siblings or with your parent. Tell them something new you learned today. All right. So that's all for today. I appreciate it a lot, and I'll be seeing you tomorrow, same time. Bye bye. See you tomorrow. Bye bye.